Hey guys, welcome back to another video, and today we're going to be solving the Leet code question, merge a sorted array. Alright, so in this question, we're going to be given two sorted integer arrays, nums1 and nums2. Our goal is to merge nums2 into nums1 as one sorted array. So notice how they tell us that we need to merge nums2 into nums1. So what that basically tells us is that we want to do it in place, and whatever we're doing, whatever changes we're doing, is going to happen to nums1 itself. Okay, so the number of elements initialized in nums1 and nums2 are m and n respectively. So in simple words, m is the number of numbers in nums1, or the number of elements, and n is the number of numbers in nums2. You may assume that nums1 has enough space or size which is equal to m plus n to hold additional elements from nums2. Okay, so there's two things that you want to kind of identify here. So one of them is that nums1 has enough space, and what that means is that the size of nums1 is the size of m plus n. So let me just show you what exactly that means. So in this case, nums1 over here, the numbers itself are 1, 2, 3, and then 0, 0, 0. So if you look at it, it's not in ascending order, right? So we were told that it's going to be sorted, but in this case, after 3, we have the number 0. But really, what this is just the numbers 1, 2, and 3. And the reason we know that is because the m value over here is 3. So what that's telling us is that we only have 3 numbers inside of nums1. And those 3 numbers in this case are these 3 numbers 1, 2, and 3. And another way to actually get to that is that this tells us that we have 3 numbers. So the last number is going to be at the index of m minus 1. So in this case, the index 2. So 1, 2, and 3. Okay, now what exactly are the other 3 values over here for? So these other 3 values are kind of just there as placeholders. And the reason for these values over here is because, as our question tells us, we're going to add the elements of nums2 into nums1. So keeping that in mind, we need to assign extra space for accommodating for these elements from nums2. So now in nums2 we have 3 elements, and we know that because n is equal to 3. So basically at the end of this, we're going to have some sort of array. So nums1 is going to have these 3 values incorporated into it over here. And the end result is just 1, 2, 2, 3, 5, 6. And again, notice how it's still sorted, okay? So that is a basic idea, and now let's see how exactly we can solve it. So the question itself is not going to be too hard, but let's just try to understand how we could solve it, and I'll be using the same example over here, okay? So the same exact example, like in example 1, and now let's see how we can solve it. So remember how I told you how we have m equals 3 and n equals 3, right? And we can kind of get the index of the last value using this, okay? So to do that, how exactly can we do it? So for m equals 3, where are we going to find the last value? So last value is going to be at the index of m minus 1. So in other words, that's just going to be over here. So the second index, so 0, 1, 2, gets us right over here. So we're going to have sort of a pointer over there. And this pointer over here is just going to kind of help us to sort the array, and we'll see how it works. And we're going to do the same thing for nums2 as well. So this is for nums2, and the pointer is going to be at the index 2 because 3 minus 1 equals 2. So it will be right over here. And notice how 1, 2, 3 is sorted, and 2, 5, 6 is also sorted. Okay, now what we're going to be doing is at each step, we are going to be making a comparison between these two. So the comparison we're going to make is between 3 and 6 in this case. So in this case, what exactly is greater? So 6 is greater. Now the question is, we know 6 is greater, and 6 is from nums2, right? And where exactly do we put this value? Now one thing you want to realize is nums1, so all changes we're doing, is going to get affected over here. Now the length of nums1 is equal to m plus n. That is the length of nums1. So this is going to incorporate both of these elements at the end of it. So keeping that in mind, where exactly is this number going to go? Now the answer to that is pretty simple. So if you just think of it intuitively, we're comparing the biggest number in nums1 with the biggest number in nums2. So since we're comparing the biggest of each of them, we just found whatever the biggest value is going to be in between of both nums1 and nums2. So in simple words, 6 is the biggest value in nums1 and nums2. So keeping that in mind, we know that 6 is going to be at the very ending. It's going to be the last element. So how exactly do we know what the index of the last element is? And that's pretty simple. So the index of the last element is going to be this over here. And how exactly do we get this value? So to get this value, all we're going to do is we're going to do m plus n, because that's the entire length of this, minus 1. So in the beginning, it's going to give us a value of, let's see, so 3 plus 3, 6, minus 1, 5. So 0, 1, 2, 3, 4, 5. So that tells us that at the fifth index, or in other words, the sixth number is going to be the largest value, and that's where we're going to place the 6. So the 6 is now going to get placed over here. So simultaneously, what we're going to do is, since we already took care of the 6 over here, and it's in the right spot, we're going to remove the pointer here, and we're going to move it to the left by 1. And how exactly are we going to be moving it to the left by 1? And that's pretty simple. We're just going to decrease the value of n by 1. So n used to be 3, and now n is going to have a value of 2. Perfect. So we're going to just continue these steps over and over. So I'll just try to go through it a little bit faster. So now we're comparing 5, or let me just write the same order. So we're comparing 3 from nums 1 with 5 from nums 2. Now in this case, 5 is again greater. So now what happened is that we know we got the largest number before this. Now we're getting the second largest number, which in this case is the number 5. So where exactly is this going to go? So since it's the second largest number, it's going to be 1 away from the very ending. So what exactly is the index? Well, the same step. It's going to be m plus n minus 1. So that's going to be 3 plus 2, 5 minus 1, 4. So 0, 1, 2, 3, 4, which is right over here. At the fourth index, we're going to have the value 5. Perfect. Now the same step, we move the pointer to the left by 1. So the pointer is now going to be here. And since we move, and the way we move the pointer is by decreasing the n value. So now n is going to have a value of 1. Perfect. Okay, so let's just keep going through this. So now we're at the number 2 and 3. So 3 and 2, and in this case, 3 is greater. So 3 is the number we get from nums 1 in this case. So now we know that this is going to be the third largest number. So keeping that in mind, we're going to do the same steps. So this 3 is now going to go over here. And to do that, it's going to go at which index? So 3 plus 1, 4 minus 1. So it's going to go at the third index, so 0, 1, 2, 3. And this is now going to have a value of 3. Now simultaneously, we're going to move the pointer to the left. So that means the m value over here is going to become 2. And since we move it to the left by 1, it's going to now, sorry, not over there. It's now going to be over here, okay? So in other words, it's going to be at the index of 2 minus 1, which is at the first index, right over there. Perfect. Now we compare 2 and 2. So when you compare 2 and 2, well, they're the same thing. So you could do either one of these. So for this, let me just actually remove this value over here. So let's remove this value, get rid of it. So what's going to happen is this is going to go at which position? So the position this is going to go at is going to be 2 plus 1 minus 1, which is nothing else but 2. So at the second index, 0, 1, 2, and it's going to have a value of 2. And simultaneously, we're going to move the pointer. So this is now going to have a value of 0. And when you have a value of 0, we actually cannot put anything over here because n is the number of numbers, right? And the index is going to be n minus 1. Okay, so the index of nums 2 is going to be n minus 1, and for nums 1, it's going to be m minus 1, right? So in this case, that means we're done with n. So when we are done with n, so actually to be more specific, when we are done with n or m, and in that case, we can stop doing these steps anymore. And the reason for that is because that means that we have reached the end of one of our arrays. So in this case, to be more specific, we have already covered all of the numbers in nums 2. And that means that all the numbers in nums 2 have been accounted for properly. And since all the numbers in nums 2 have been accounted for, we can directly assume that everything in nums 1 is also accounted for. And the reason being because everything in nums 1 is already sorted, and whatever changes we are making is happening to nums 1 in place, okay? So if n is done with, then we're directly done with our solution. And what's going to end up happening is we're going to have this. So if you want to compare this to our answer, it's correct, right? So we have 1, 2, 2, 3, 5, 6. And it is sorted and it has the numbers 2, 5, and 6, which were not there earlier on, right? So that is exactly what happened. And now this over here works out and we would actually get a correct answer. But one thing you want to look at is in a case, so let me just actually show you an example. So this over here is going to be nums 1, and the m value over here is going to be 0. And we're going to have 0, 0. So when you have an m value of 0, that means that nums 1 does not have any numbers in this case, okay? So that's what we're starting off with. And over here, I'm going to have nums 2, and I'm going to have nums2 have two numbers, which is 1 and 2, and in this case, n is going to be equal to 2. Now let's see, how exactly do we end up solving this question? So like I told you earlier, whenever the m value or the n value ends up becoming 0, then in that case, we kind of stop doing our iterations over here. So in this case, we start off with the m value of 0. So this is one way you could do it, or another way would be, so you would be doing these iterations above each time, and at one point you would reach a point where m is equal to 0. Now what exactly does it mean when m becomes 0 at any of those points? So that means that we've already accounted for all of the numbers which were in or exclusive to nums1 itself. And that also means that we did not take care or include all the numbers in nums2. So again, I just want to say one more thing. So previously, when we did not account for, so in this case, we stopped when m was equal to 2. And that's fine because we are ending up returning this array as it is. So it's fine, right? They're already accounted for. But in this case, when n is equal to 2, that means that there's still some numbers in nums2 which are missing and have not been accounted for. So this over here is going to be a separate or an additional condition which we need to take care of. And we're only going to have to take care of this condition when n is greater than 0. So that's only when we need to take care of the condition. Okay, perfect. So this is what we're looking for. And what exactly are we going to do over here? So it's the exact same steps. So is there going to be a pointer for m? No, there isn't. So because m does not have any values as it is. So the pointer is only going to be over here for the nums2. So same thing, it's exact same step, okay? So over here, where exactly is this value going to go? So this value is the greatest value as it is. So it's going to go at the position of m plus n minus 1. So that's going to be 2 minus 1, which is nothing else but the index 1, okay? So at the index 1, we're going to have the value 2. Simultaneously, we get rid of the pointer, we decrease n by 1, so n now has a value of 1. And this over here is going to be our pointer, so we're at the number 1, and now where do we place the number 1? So the number 1 is going to be placed at the index of m plus n minus 1, which is at the 0th index, and this is where 1 is going to be. And at the very ending, our n value becomes 0, and we are done. So at this point, this means that we have now accounted for all of the numbers at where n is for nums2, and now nums1 has all of the numbers of nums1 and nums2, and now we can just directly return this as it is. And actually, we wouldn't be returning anything since everything is going to be happening in place for the solution. So I'm pretty sure you should understand how this works. I think it's not too difficult. And do let me know if you have any questions, but for now, let's see how the code of this looks like. Okay, all right, so I'm going to be doing exactly the same thing which I told you about in our previous example. So over here, we're going to have a while statement, and we're going to keep going until m is greater than 0 and n is greater than 0. So we're going to go until both of them have some sort of value to compare with. Okay, now over here, we're going to make the comparison. So the comparison we're going to do is if nums1, and which index do we go to over here? So we're going to go to m minus 1. And the reason we're doing m minus 1 is because m over here starts counting at 1, but our indexing starts counting at 0. So that's where we're doing m minus 1. And we're going to compare this and see if it is greater than nums2 n minus 1, okay? So we're comparing both of these values. And if this is true, right, so if whatever is in nums1 is greater, then what we're going to end up doing is we need to add this value in the correct position. And to do that, we're going to go to nums1. And the index we're going to go to, like I showed you, is going to be m plus n minus 1. And this over here is going to be equal to this value that we're currently on, since it is the greater value, okay? So that's exactly what we're doing. And simultaneously, we're going to decrease our m value by 1. Perfect. Now, if this is not the case, that means that either the values are equal to each other, or this over here is greater. So that means whatever is at nums2 could be the greater value, or sorry, is the greater value or equal to the same thing. So in this case, the exact same thing over here is going to end up happening. We're going to put it in the right position for nums1. We get the index by doing this, but instead, the greater value is nums2. So we're going to copy that over and put that over there, okay? That's it. And simultaneously, instead of decreasing m by 1, we're going to be decreasing n by 1. So n minus equals 1. And that should be it. So at the very ending of this, we're going to exit out of our while loop. And if we exit out of our while loop, by exhausting all of the values at n equals to, not n equals to, at nums2, then we're good to go. But there might be a condition where we do not get everything from nums2. So to make sure that we got everything from nums2, we're going to do while n is greater than 0. And the reason we're doing n is because n comes from nums2. So if n is greater than 0, that means we did not account for all the values, and that's what we're doing over here. And to do that, we're going to go to nums1 because that's where we want to place the value, and we're doing the exact same thing, which is we're going to this index and we're placing the value. And the value that we're going to be placing here is going to be from nums2 because, well, there is nothing in nums1 and we don't need to worry about it. And so each time we're going to be decreasing our value, and we're going to decrease the value until n ends up with a value of 0. Now, in this question, we don't need to return anything because they want us to modify nums1 in place. So as you can see over here, this should be it. Submit our solution. And yeah, so thanks a lot for watching, guys. Do let me know if you have any questions. And don't forget to like and subscribe. Thank you.